We're looking at the question one. Find the general solution of this second order differential equation. You can see your second differential, okay, first differential, and the constant. So without wasting time, so your when you see second differential, the second differential will indicate r squared. Okay, that's your second differential. Your first differential represents what? This. Okay, so this equation will now become the auxiliary equation is what do you have here? R squared. This will equal to minus 5r then plus 1. The one without differential, that will be constant, plus 6. What we do now is that if you like, you can use quadratic formulae, or you can use a factorization method. Let's check. Is this one factorizable? Let's check that. That's r minus 3 is equal to 0, or r minus 2 is equal to 0. So therefore here r equal to 3, or r equal to 2. Okay, so what we now do is that you can, anyone could be your r1, this will be your r1, this could be your r2. Okay, so the general solution, the general solution is y equal to c1 y1 plus c2 y2, and that's equal to c1. Your y1 is the y1 will be equal to e3 what? 3x. Your y2 will be equal to what? e2x. So that will be equal to e3x plus what? E what? E at 2x. C2. So that's your general solution for this second order differential equation. Okay. So that's that on that. Next question. And then in buttress to that, this is case one, where you have two distinct green roots. Okay, this is case one of the previous video. For this question two, the auxiliary equation W r squared, then minus 2. These are the coefficient and the constants. So that minus 2r, okay, then plus constant. The attachment here is what is 1 plus 1 equal to 0. Okay, so in that case now, we can factorize this equal to 1. Okay, and this is what? Repeated roots. This is repeated roots. So I can say that this is equal to repeated root, which means r1 is equal to r2. And that's equal to what? That's equal to 1. Okay. So in that case now, without wasting time, the solution of 1 will be equal to y1 will be equal to what? E. This is 1. That's power x. And then y2 will be equal to what? Ex, and then times what? Times x. If you have repeated, we have one repeated root, times equal to 1, equal to r1, r2. Okay, that's case 2 of the previous video. And then we can get the general solution of this. The general solution will be equal to what? Y will be equal to c1 and equal to what? c2 equal to what? X. This c2. So that's the general solution for that. For this question, this is a third differential, this third differential, this second differential, this fourth differential, and it's homogeneous. Your g of x is equal to 0. So this is homogeneous. What do we do now? So if it's y3, that would be what? That would be r3. Okay. So, and there is no constant coefficient here. So that will be equal to r3 plus 3r squared, and then plus 3r plus 1 equal to 0. So this is polynomial of power 3, of degree 3. So what do we do now? How do we factorize this? So that's the question. Now what we do here is that we can first of all take this as a function of r. Take that expression as a functions of r. Okay? Take that. Then let's begin to look for factors of 1. Factors of 1 could be minus 1 times minus 1. Okay, 1 times 1. Oh, these are factors of 1. So we're going to check those are factors. We're going to check minus 1. Minus 1 is the factors of 1. So let's check. We're going to check that. You can take a calculator. If you plug in minus 1 here, will it give us 0? We want to know if minus 1 is a factor of this. Okay? We want to know if it's factors of this. And I've told us that 1 has 2 factors. It will be minus 1 times minus 1. Because this is plus 1. And it can also be 1 times 1. So we want to check minus 1. We want to check 1. So let's first of all check minus 1 and plug in this if it's a factor. If it's a factor, then the expression will be equal to 0. So this is minus 1. This is plus 3. This will be minus 3. And this will be what? Plus 1. So this one cancel. And that's equal to 1. That's equal to 0. So in this case now, f of minus 1 means what? It now implies that r plus 1 is a factor. R plus 1 is a factor. This is a polynomial techniques. So r plus 1 is a factor. So if r plus 1 is a factor, then we can do the division to factorize that. To do our division, this will be this, plus this, plus this, plus this. Then we are dividing by what? R plus 1. Okay? So in that case now, this will be r squared. So r squared times this, that's r3. R squared times 1, that's what? That's r squared. We can subtract. So this will cancel. This will give us what? Plus 2 r squared. Okay, then you can bring down the next value. That's plus 3r. Okay, so then we need what? Plus what? Plus 2r. Okay, we need plus 2r. So plus 2r times this, we have what? 2r squared. Plus 2r times 2, that's what? Plus what? Plus 2r. Can subtract also. So this will give you 0, and this will give you r. Then you can bring down the other value, plus what? Plus 1. So in that case now, what is factors of r here? That's plus 1. So that by the time you multiply with this, your dice of the first value, you get your r also. So 1 times r is r, and then 1 times this is also plus 1. So that's 0. And the thing you have to know is that automatically, if r plus 1 is a factor, then your remainder will be 0 when you do your division. Okay, and that's what we have done in that case now. So therefore, this expression r3 plus 3r squared plus 3r plus 1 is equal to r plus 1 times what? What was our this one? If you multiply this one times this one, you get back your function. You get back your function. So that will be r squared plus 2r and then plus 1. So this is linear. Then we also get this one as linear too. So that will be equal to r plus 1. Okay. This one will be what? Let's do that. Factors of 1. That's 1 times 1. Okay. How can we use 1 and 1 to get a plus 2? So that will be equal to what? Plus 1 here. Okay. Here also plus 1. Okay. You factorize this. You have this. This is advanced class. So I think so in that case now, we can now come back here. Okay, we can come back there, and that's equal to what? R plus 1, okay, into bracket R plus 1, into bracket R plus 1 is equal to 0. Okay, and this implies that here, from here, R is equal to what? This is equal to 0. R plus 1 is equal to 0. We have minus 1 here. Here also, or R is also what? Minus 1 here too. Here also, R is what? R is, let's see how we can get our general solution. R1 is equal to R2 is equal to R3, and they are all equal to what? They are all equal to minus 1. So what we do here is the solution of this will be equal to y1 will be equal to e minus x. Y2 will be equal to what? If it's repeated root, if it's one repeated root, so times what? E minus what? Minus x. Then the next one, since we have R1, R2, R3, the next one will be equal to Y3 will be equal to what? Times x again. X squared e minus x. So these are the solution of the differential equation. Then we can get the general solution is y equal to c1 y1. So that's the general solution for this question. The question is very interesting. Okay, so that's that on this question. Okay.